Okay, because we're going to use degree and lead coefficient when we start doing some of these graphs today. All right, hopefully you got them. You didn't overthink it. Degree, of course, is the highest exponent. So this guy's a 2. This one's a 3. And then, of course, I know you know the lead coefficient. I'm just going to abbreviate it LC. Of course, is our first number. Now, that's a little subjective. It's our first number if your polynomial is written in the correct order, highest exponent to the lowest. So be conscientious about the order. This one, of course, is in the right order, so 5. So today you're going to have to be able to identify the degree, and we're going to use lead coefficients on some of the problems too. So just a vocab review. Now, we're also going to talk about domain. These are some examples of some rational functions. Rational is a fancy name for a fraction. Okay? This is kind of leading us up to a review, a reminder of our domain. Determine the value of x that make each of the following undefined. Well, when is a fraction undefined? When what number is under the line? 0, I heard it. So what number makes this 0? When x is what? -5. So just to throw it back to the first chapter, if we were doing domain of this, which we will be in a minute, I would say all real numbers, x can equal -5. What's the one number for x you can't use in B? 7. Now, C. I got fancy on you. I gave you a quadratic. There are 2 numbers, 2 since it's quadratic, that you can't use in C. I would try to factor this and then figure it out. They're always factor first, right? There are 2 numbers that multiply to 12 and add to 7. 3 and 4. Now, hopefully, it's easy to figure out what 2 numbers, 2 of them, can you not use for C? -3 and, got it. So again, that's just a little review to get you thinking about domain when you have a fraction, because we are going to have to give the domain of these. We are going to need to know degree and lead coefficient when we start getting into asymptotes. Now, here's a bunch of vocabulary. Like I said, I don't know if you got into this or not last year. We're going to be talking about vertical up and down, horizontal left and right, asymptotes, and drawing the graphs. We're also going to have a slant, diagonal line, a slant asymptote. I'm going to show you how to find all of that stuff. Because that's the one thing, I love to complain about Texas Instrument. I do a lot on this stuff. That is the one thing, like your calculators will not show you, are the asymptotes. They'll show you the curves and the graph, but they don't show you those vertical and horizontal lines. So you are going to have to be able to do those by hand. Can you maybe kind of look at the graph and take a guess? Probably, but they won't specifically show them to you. All right, rational function, of course, is a fraction. That's all the top is showing you. It's going to be fractions today. Now, the first thing I always find, start easy, right? I think this is the easiest thing, is the vertical asymptote. A line the graph approaches from left or right. Approaches. So you don't touch it, you don't cross it, unless you can't draw like me. So we're going to draw close to these lines. We're not going to cross or touch. Simple. To find it, you set the denominator. I'm going to say by setting the denominator equal to 0. So that's going to make it undefined. Kind of like when we talked about domain. We're not going to cross or touch it. Now, horizontal asymptote is going to take a little more investigation. Not hard, but just a little more thought to it. To do the horizontal asymptote, you're going to have to look at the degree of the highest exponent, of course. Now, choices. The degree of the top could be smaller. So you could have like x squared over an x cubed. You could have the degrees being the same, like an x squared over an x squared. Or we could have the third possibility, the top's bigger. So that's the first thing you're going to have to check, are the exponents, and which of these situations you fall into. Top is smaller, same, top's bigger. Now, if the top is smaller, this is my favorite because you don't have to do any work. Whenever the degree of the top is smaller than the bottom, automatically y equals 0. Nothing to think about, no work, 0, got it. Now, if they are the same, squared and squared, then here's the vocabulary from the warm-up. It's the lead coefficients over each other. So I'm going to get fancy and say it's the ratio. That just means fraction, ratio of the lead coefficients. I'm going to abbreviate because I'm running out of room there. Now, the third possibility, which we're going to save this one for the end. I will do it, but we're going to do it at the end. Let's say the degree of the top is bigger than the bottom. Then it kicks you into a slant, a diagonal asymptote. That's different. We're going to hit that at the end, but I just wanted to address it, what does happen when the top degree is bigger. So because I don't know if you covered many of these last year, so I'm kind of going through all of this in detail. I don't know if you got into this or not. But the next thing we're going to talk about is what we call a point discontinuity, or a hole in the graph. Now, I'm going to try not to rant about Texas Instruments. If you just graph these, it's not going to show you the hole. You're either going to have to look in the T-chart for an error message, which I'm going to show you that, or there is a special setting under Zoom that will show you the hole, and I'm going to show you all of that. So when does it exist, though? When you have a common factor. So you factored the top, you factored the bottom. Let's say you have x plus 1, x plus 1. You have a common factor, the same thing. To find your hole or your point discontinuity, you take that common factor and set it equal to 0. And we will get into that. So the first three that we're going to graph are what I call pretty standard, basic, no frills, nothing exciting graphs. And then we'll look at something maybe a little more intense, a little more exciting. So, I mean, 1 over x squared, you're more than welcome to type it in y equals, hit graph, look at it, get a table going. I don't care. I'm going to draw it by hand. Now, it asks us to start with a domain. So, review of chapter 1. Domain, of course, what you're putting in for x. So, just like those warm-up problems that we talked about, fractions, I can use any number I want except for which one? What's going to make the bottom 0? 0. So I'm going to say, real numbers, x can equal 0. Now, your domain and your vertical asymptote are always going to be related. It's kind of what I say a 2 for a price of 1 here. So to do our vertical asymptote, that's the next thing I'm going to find because I think it's the easiest. So I'm just going to click it back a couple slides here. To do your vertical asymptote, we set the denominator to 0. Well, that seems easy enough. So x squared equals 0. I'm going to get rid of the squaring. And notice, your domain, your vertical asymptote always are related. This is what you cannot use for x, so that's going to be your boundary line when we draw our graphs. So I'm going to hit 0. I'm going to draw a vertical, I know it's hard on the axis, I'm going to draw a vertical dashed line. I'm not going to cross or touch this when we actually get the graph going. Next thing I'm going to find, horizontal. Well, you finish marking that. I'm going to just go back a couple slides here. Now here's where we have to compare the degrees. Now horizontal, we're going to have these first two cases right now. We're not to a slant yet. We're either going to have the degree of the top being smaller, 0, or they're the same, the coefficients. Let's see what we got. Well, first thing, I don't even like that there's not an x on the top. Technically there is. We got to be smart here. 1 is the same as x to the 0. Anything to the 0 power is really a 1. So I'm looking now at my degrees. I've got 0 and a 2. Okay, all right. So whenever the top's smaller, it's always, you don't have to do any work, y equals 0. Whenever the degree of the top is smaller, no work. All right, let's draw that. So if you type that equation, that function into your calculator, it's not going to give you these lines. It's just going to show you the curves that I'm going to draw here in a minute. Now I'm just going to old school T-chart it. You can, of course, look in your calculator, I don't care. If you're doing it by hand, your asymptote's at 0, so I just put in a number on either side. So I'm going to plug in -1 and 1. And I'm just going to punch them in, calculate it, whatever. So if I put -1 in here, -1 squared is 1. So you have 1 over 1. -1, 1. I'm going to plot that real quick. Then I'm going to put a 1 in for x. 1 squared, 1. Okay, those 2 points are all I need to draw the curves. So if you graphed it on your calculator, it's going to look like this. Your curves get close to the horizontal asymptote, close to the vertical. Same thing on this side. Close to the horizontal, close to the vertical. So your graphing calculator will give you those blue curves I drew. It will not give you the dashed asymptotes. You're going to have to do those yourself. Not that that's the end of the world. Okay. Any questions on A? All right, let's do B. Again, let's start with some easy standard ones. Of course, you could punch that in your calculator. Personally, I don't like the order on it. We're not in the correct order. It should be x plus 2 and negative x plus 2. Should be in the correct order. I don't know why they can't make it that way, make it easy on us. Okay. So first I'm going to do domain and then my vertical asymptote. Remember, those are always related. So domain, I don't care if you look at the correct order or the original. What's the one number you cannot put in there for x that's going to make it undefined? 2. I see hands up 2. Our real numbers, x can equal 2. Now, here's because we know our vertical asymptote is always related. I don't even do any work for my vertical if I know the domain. I know my vertical asymptote, then it's going to be the line x equals 2. You want to get technical about it, you're setting the denominator equal to 0. If you solve it, you'll get x equals 2. Well, I do extra work, right? Okay. So I went ahead and drew that. Now I'm going to do the horizontal. Now the horizontal, remember, takes a little more investigation. You have to look at your degrees to the first to the first. When the degrees are the same, it's the lead coefficients. So the lead coefficient on the top is a 1. Lead coefficient in the bottom is a negative 1. I'm just going to divide that out. So when your degrees are the same, so many 1s, when I'm looking at the power of 1, when those are the same, it's the lead coefficients over each other. Let's draw that. Now, I'm going to, of course, t-chart it by hand. If you're typing it in your calculator, no judgment, I don't care, but because you have binomials here, make sure you put parentheses around it. Otherwise, it will mess up your order of operations and potentially your graph. Okay, I'm going to go old school. So my asymptote's at 2. I'm just going to pick a number on either side. I'm going to use 1 and 3. I'm going to calculate them out by hand. You could get it off the calculator. I don't care. Let's put 1 in. 2 plus 1, 2 minus 1. So I have 1 comma 3. And I'm going to put 3 in for both x's. 2 plus 3. And then 2 minus 3. And again, it doesn't matter which version you put it in. I just like it in order when I do degree and lead coefficient. 1, 2, 3. Got it. So now those 2 blue dots, enough for me to draw. Close to the vertical, close to the horizontal. So again, your calculator will give you the blue curves. It will not give you the dashed lines. You're going to have to be able to do those. I'm going to give you a minute to draw those. And then we're going to do one more kind of basic function. But this one, get ready for it, is going to have a point discontinuity, a hole in it. All right, let's do the last one. So how do I know this has a hole? Because I made the problem. But I'm looking at that and I'm like, dang, there's a lot of x's. Every term has an x in it. So I'm going to factor an x out. So GCF out of the top, and GCF out of the bottom. So all I did was factor. Nothing fancy yet. I'm just going to click it back a couple slides. So how do I know there's a hole? There's that common factor. There's the same thing on the top and bottom that I factored out. I took an x out of the top and x out of the bottom. So to find the hole, I'm going to set the common factor to 0. Okay, so because these would cross off, of course. So I'm just going to put a little note. We'll get to it. To find my hole, I'm going to set the common factor, which was x, to 0. And we'll work on that. I'll get into it eventually. But let's do, like we've done on the others, domain, vertical asymptotes, and then I'll do the horizontal. Now, always easier to work off the simplified version. So I'm going to work off this guy here. Domain, real numbers. So this time, of course, if you're like, oh gosh, I don't know what x can't equal, it's going to be a fraction, I can't figure it out, quote unquote cheat the system. Do your vertical asymptote first. Set the denominator to 0. Because remember, these are always related. I can solve that in my head. Add 1, divide by 2. So that's my vertical asymptote, and that's the one number then I can't use for x, which I'm like, oh yeah, okay. Because if you put a half in here, 2 times a half, 1, 1 minus 1, 0. 0 under the line's undefined. So glad it's a half. That really helps my drawing skills. Okay. Whew. Try to draw it as best you can. I'd never make a good surgeon. I don't have a steady hand. All right, then for the horizontals, not hard, but a little more work. You got to look at our degrees. We have x to the first, x to the first. So when they are the same, it is the lead coefficients. So the lead coefficient on the top is a 1, bottom is a 2, so 1 over 2. Oh, good. More fractions for me to try to draw super swell. Love a good fraction. Now again, you could get the t-chart off your calculator. I'm going to do it by hand still just to practice. Now, our asymptote is at a half. Don't think I'm doing fractions in the t-chart. I'm going to go 0 and 1. And again, just to reiterate, it doesn't matter whether you plug the 0 and 1 in the original or the simplified. You'll get the same thing. It's just easier to work off the simplified, in my opinion. So I'm going to put 0 in here for x. 0 plus 2, 2 times 0, 0 minus 1. So I have 0, negative 2. Got it. So I'm going to draw close to this, close to that. Then I'm going to put 1 in for both x's, 1 plus 2, and then 2 times 1, 2 minus 1. So 1 comma 3. Got it. Okay, now before we think we're done, we've got to talk about this. I've got to mark the whole, the point discontinuity. Now again, why do you have it? Common factor. The other two problems, you're like, how come we didn't have any others? Nothing factors on that. I can't factor anything out. Nothing factored on that. This is the first time we have something that's factorable that came up on us. So to find the whole, we set our common factor to 0. There's nothing else to solve for there. We want a coordinate, of course. So just like any time you know x, plug it in to get y. But I'm not going to reinvent the wheel here because I already put 0 in. So I'm just going to copy that. And then over here on my smart board, I'm going to go to 0, negative 2 and put an open circle for the whole. It's very hard for me to erase that little teeny tiny dot out of there. So if you look in your t-chart, it'll have an error message when x is 0. And I'm going to show you one on the calculator here when we get to it. I just want to do the first few by hands. Do you remember, did you do this last year at all? Some yes? Okay. All right, good deal. So just to try to help the cause here and give you some words of wisdom and some advice here how to tackle these, that's kind of what this is going to summarize. So first up, I always try to simplify. So that's like that last problem. I'm going to try to factor and cancel. So it's like the very last one. Now, out of the 3 we did, only one of them factored and canceled. It doesn't always happen, just is what it is. Then they're going to ask you for x and y intercepts here. So let's do y-intercept by doing what's getting technical here, f is 0. You know this, we're just putting 0 in for x. Now, I'll be honest, on these, I very rarely do them algebraically. I just look at the picture and see where it hits the x-axis and write it down. Pretty easy. Same for y. All right, let's do x-intercept. X-intercepts, again, very rarely do I actually do them algebraically. You can just set the numerator equal to 0. Or you know this, you're putting, of course, 0 in for y. Now again, rarely do I do it by hand. I just look at the graph and figure out where it hits the axis. Make it easy. All right, next I always like to work easiest to toughest, right? I do the vertical asymptote by setting the denominator to 0. So by finding the zeros of the denominator, the bottom. Then I do the horizontal asymptotes. Not that those are tough, but it takes a little more thought process. By examining the degree. So much vocab. Now remember, degree is your highest exponent. And then it's just a matter, this is just a long-winded word way of saying, make your T-chart. Get a point that's on either side of your vertical asymptote. So plot one point beyond and one point between each x-intercept and vertical asymptote. So just get the points, whether you're doing it by hand or off your T-chart. Connect, make the curves. All right, let's do it. So sketch the graph, answer the stuff, find the asymptotes, etc. So this is one I do have punched in the calculator. I'm going to pull it up just to show you here. We're going to do everything by hand, right? So first up, factor and cancel. Can you factor and cancel on this? Sure can. Top is perfect squares. So I'm going to factor it into x plus 1, x minus 1. So always check for that first. Then I'm going to, of course, cancel. Now, because we have that canceled common factor, I'm going to add something on here. We're going to have a hole. And of course, we set that common factor. I'm just jotting myself a note so I don't forget. Set that common factor to 0. We'll solve it and do it in a minute. Now, just to show you, so this one, of course, I punched in on my calculator. Let me get it activated here. So it doesn't matter if you do the original or the simplified. My advice on your calculator, though, if you're using your calculator, I would always do the original. Because what if you screw up the simplified? What if you miss factor? Oh, that's going to be bad for you. So I always put the original one in, just, you know, in case I make an error. Now notice, too, I've got parentheses around the top and bottom. If you don't have parentheses around the top and bottom, it's going to mess up your order of operations. All right, I'm going to hit graph. Huh, it's interesting. You have a diagonal line. Doesn't look like any of the other graphs, no crazy curves, but then I'm like, well, yeah, let's look at our function. We've got f of x, and we're left with this. mx plus b. We're in slope-intercept form. I can draw a diagonal line all day long. Slope of 1, y-intercept -1. Let's get that diagonal line drawn. There's my y-intercept, slope of 1, up 1 over 1. I just put a lot of points on because I can't draw. Let's take a look at the graph. Looks pretty good. Looks like it. I like it. I like it a lot. Let's try to answer some of this stuff. Now, this is what I'm saying. I try not to do these two algebraic. Just make it easy on yourself. X-intercept. Yep, got it. Bam, right there. Hits the x-axis at 1. Want to make that any harder? Glad you made it, Maddie. Okay, y-intercept. Got it. It's the y-axis at -1. Piece of cake. Let's look at the graph. Asymptotes. Is there some vertical line it looks like we're not crossing or touching? Sure doesn't. It's a line. It goes on forever. So we don't have any this time. And the reason also why, when you simplify, you're out of a fraction. You're not a rational function. Same on this. Now, let's talk about this hole. When you look at the graph, you're going to be like, dude, there's no hole on it. Remember, we hate Texas Instruments. These aren't the best. There is, okay? So to find it, we set our common factor to 0. I'm going to solve that in my head. We get -1. And then I'm going to just, a little mental math here. I'm going to put -1 in here for x. -1 minus 1. Okay, got it. So at -1, -2, I'm going to draw my hole. Now, let me show you how to see it on your calculator so, you know, I'm not lying to you. 1, you can look in the table. When you have -1 for x, it says error. That's the problem. Okay, that's why there's a hole there. If you want your graph to actually show it, to display it, it will. You have to, why, I don't know, I don't have an answer for this. You have to do zoom and number 4 decimal. And there you can see there's a little tiny gap, a little tiny hole in the graph. But if you want to actually physically see the hole on your screen, you might want to make yourself a note. You have to do zoom and then number 4 decimal. I don't know why I can't just show it when you hit graph everything, but I'll try not to get on a rant about Texas Instruments. All right, zoom 6, of course, puts you back to the standard. Don't just trust the picture that it shoots out at you. I'll try not to get on it. Okay, any questions on that guy? That's kind of a unique one. All right, so now we're going to talk about this. Let's get into this. So let me back up the truck here a minute. We're on, we haven't seen it yet, this third possibility down here. If the degree of the top is bigger than the bottom. Now we're going to have a slant, diagonal, asymptote. So first I'm going to write down when it happens, degree of the top is larger than the bottom, and then I'm going to tell you how to find it. You're really going to love that. Okay, so first, when do we have it? Degree of the numerator is larger, or bigger, whatever you want to say here, than the denominator. So that was, I gave you that little example, like x cubed over x squared. The top is bigger. Now here's the fun part of this, to find it. Well, let's see, rational functions, they have that fraction bar. Fraction bar, of course, means division. We're gonna do some long division, yes. So to find it, we're gonna divide. Now, could you use synthetic? I mean, depends on the divisor. I'm going to put long / synthetic. Most of the time it's long. I'm just going to rip the Band-Aid off now. Because remember, synthetic only works if your divisor is a binomial, 2 terms, degree 1. That's a very rare case on these. So I'm going to probably be doing some long division. All right, so sketch the graph, answer the stuff, you can read it. Notice it is switched from horizontal asymptote to slant because your degree at the top is bigger than the bottom, okay? So on your homework, I mean, it's telling you here on your notes, but obviously on your quiz, you have to know when you have a horizontal versus a slant. You're going to have to be able to tell me that it's a slant because the degree of the top is bigger. You're going to have to identify it. Today, kind of nice. All right, now same rules. I'm going to see, can I factor and cancel? No, there's nothing to factor and cancel. So then I'm going to do the vertical asymptote next. I'm going to set the denominator equal to 0. Well, nothing else to solve there. That is what it is. Let's draw it. Now I'm going to do the slant. Now I'm going to have to divide because fraction bar means divide. Can I use synthetic? I cannot because our divisor is a monomial, 1 term, not 2. So long division. So we've got 2x squared plus 1 divided by x. So this is the yuck part, of course, having to do the long division. So we're ready to figure out what goes on top. What times x is 2x squared? We need a 2 and an x. And of course, which by the way, long division looked fabulous on your test last week. We're going to subtract that. So remainder is 1. Now slant, we want a slant asymptote. I want an mx plus b style line. I do not want some little stupid fraction remainder. So we're not using the remainders today. So on my slant asymptote, I'm going to fill in y equals, we got 2x for an answer, 2x. So I'm not using the remainder. I don't want to be graphing some credo fraction. We just need the slope-intercept part. So of course my slope, my b, and I don't come back there, of course, would be 0. I want to get fancy about it. So let's draw that. Y-intercept 0, slope up 2 over 1. Same spiel. I'm going to make a T-chart. I'm going to do mine by hand. You can get yours from the calculator. I don't care. Now, my vertical asymptote is at 0, so I'm just going to go on either side. I'm going to use a -1 and 1. I'm going to put them in for both x's. -1 first. -1 squared, 1. Times 2, 2. Plus 3, 3. -1 at the bottom, so I have -1, -3. Same deal. I'm going to draw close to the vertical, close to the slant. So you get kind of some curves on these. All right, let's put 1 in. 1 squared, 1. Times 2, 2. 2 plus 1, 3. Over 1. Got it. Close to the vertical, close to the slant. Got it. Now, again, I try not to overthink the intercepts. Let's look at the picture. Remember, the true part of the picture are the blue curves. Where do the blue curves touch the x-axis or the y-axis? They don't, right? That's okay. We don't have to. We don't have any. All right, one last one. And I'm going to use my calculator to help us on this one just to practice doing another one in the calculator. Now, first, has a slant asymptote, just to review, because our degree at the top bigger than the bottom. Still working in the same order as always. Now, I can't simplify anything. I could pull a 2 out of the bottom, but it's not going to cancel. It's not going to reduce anything, so I'm not going to waste my time. Vertical asymptotes. I'm going to set the denominator equal to 0. I just wrote it on the side because I got to obviously do a little work. Now, choices. You can factor a 2, factor some more, add 8, divide by 2. I don't really care. Just get it solved. I'm going to add 8 over, divide by 2, and then I'm going to root it. Again, you could have solved by factoring. I don't care how you solve it. That's your choice. Plus or minus 2 we got. Oh, we got 2 of them. Great. Sounds fun. All right, let's draw them. Ready? And the slant. Now remember, that fraction bar means division. So I am dividing. The question is, am I doing synthetic or long? Well, your divisor has squared in it, so we're doing long again. X cubed divided by 2x squared minus 8. Yeah, the good stuff, the long division. Okay, this involves a fraction too. What times 2x squared is 1x cubed? Well, I know I need another x. That makes the x cubed. But what fraction am I going to have to multiply 2 by to turn it into 1? How much of 2 do you need to get it down to a 1? Half. Half times 2. Half times -8. Subtract. Subtract. Remainder, which I don't care about. So I'm going to put down my slant asymptote as y equals 1/2 x. So y-intercept 0, slope 1/2. Okay, so we've got a lot on this one. So again, this one I'm going to pull up on the calculator just to show you and practice and whatnot again too. So let me turn this one off. Okay, so again, just using your calculator, reminders, 1, parentheses around if you have more than one term. 2 terms in the bottom, so notice I have parentheses around it. And I would also always graph, I didn't have to simplify on this one, but if you do, always graph the original. That way if you made a mistake, it won't affect your calculator. All right, let's hit graph. So the red curves are clearly the graph that I'm after. I'm like, oh boy, that looks super fun. So I'm just going to work left to right. I'm going to start over here in this left corner. I'm going to get a point on that. So second table. Okay, so my asymptote's at -2, so I'm looking for something to the left of it. So I'm going to use -3, -2.7, estimate it best I can. Close to the vertical, close to that. Okay, all right, I'm liking it. Let's put the graph back up. I'm just going to steal the picture so it's in front of us here. So now I'm looking for this kind of curve in the middle. So let's get some points off the t-chart. Again, I'm not going to get too carried away. What do we got? Well, not using the error. So -2, oh gosh, -1.2. Okay, got it. I'm going to estimate it. 0, 0. So notice, too, I wanted to point out, you can hit a slant asymptote. You can't touch a horizontal or vertical, but you can hit a slant, just for the record. Okay, and then I'm going to use, gosh, I don't know, 1, -0.2. And remember, I'm going to draw it so it looks like this, of course. I'm going to try to draw it so it looks like that. No promises. And then I need this right piece. So back to the table. So let's use something on the right of 2. I'm going to use 3, 2.7. Draw that curve. Whew, that's a good one. So again, don't feel afraid to use your calculator. I didn't even want to do the t-chart on this one by hand. But just be careful on your calculator that you are putting parentheses around this. Now hang on, hang on. Maybe you've already answered it. What did you fill in for intercepts? Where does my blue curve hit the x-axis? 0, 0. Where does it hit the y-axis? 0, 0. Don't overthink it. I'm right on the picture. Got it. Okay. Just wanted to fill them in. So any questions on that? All right. So here is the deal.